What if time itself could end? It's a question that feels almost impossible to grasp. Time is the invisible thread that weaves through every moment of our existence, the constant backdrop to our lives. Yet, scientists and philosophers have long wrestled with the idea that time, as we know it, might not be eternal. It's not just the stuff of science fiction. It's a real possibility that could reshape everything we think we understand about the universe. From the collapse of reality as we know it to the eerie silence of a frozen cosmos, there are at least 25 chilling theories about how time could meet its end. Each one challenges our perception of reality, forcing us to confront the fragility of existence itself. So, let's start with a theory that doesn't just question the end of time, it questions whether time as we experience it even exists at all. As we peer into the vast expanse of the cosmos, one of the most haunting questions lingers: how will it all end? The first theory we'll explore is the Big Crunch, a scenario as dramatic as it is unsettling. Picture this: the universe, once expanding at breakneck speed, begins to slow. Gravity, the silent architect of the cosmos, tightens its grip. Galaxies, stars, and planets, everything we know, are drawn inexorably inward, hurtling toward a single, infinitely dense point. This is the Big Crunch, a reversal of the Big Bang that would collapse the universe back into a singularity, erasing time itself in the process. The science behind this idea hinges on a cosmic tug-of-war. For decades, we've believed the universe is expanding, driven by dark energy, a mysterious force pushing galaxies apart. But what if that force weakens? What if gravity, relentless and unyielding, gains the upper hand? The result would be a universe that folds in on itself, compressing all matter and energy into a speck so small, so dense, that the laws of physics as we know them would cease to exist. Imagine the final moments: stars crashing into one another, galaxies merging in a chaotic dance, and the fabric of spacetime itself crumpling like paper. It's a cosmic crescendo, a symphony of destruction on a scale beyond comprehension. Yet, as chilling as this vision is, it raises a profound question. Is this the only way the universe could meet its end? Could there be other forces, other possibilities, lurking in the shadows of our understanding? The Big Crunch is just the beginning of our journey through the myriad ways time itself could unravel. Imagine a clock slowly ticking, each second marking the passage of time. But what happens when the clock winds down, when all its energy is spent and the ticking stops? This is the essence of the second theory we're exploring today, the heat death of the universe. At its core, this theory is about entropy, a measure of disorder in a system. Over time, entropy increases, meaning the universe is gradually moving toward a state of maximum disorder. Think of it like a cup of hot coffee left on the counter. At first, it's steaming and full of energy, but as time passes, it cools down, its heat dissipating into the room until it reaches the same temperature as its surroundings. The universe, too, is cooling down, spreading its energy thin until everything is uniformly lukewarm, dark, and lifeless. This is the heat death, a distant future where stars have burned out, galaxies have faded, and all usable energy is exhausted. The cosmos becomes a vast, cold expanse with no light, no heat, and no movement. It's a chilling thought, isn't it, to imagine a universe where time itself seems to stretch endlessly, but nothing happens. No new stars are born, no planets orbit, no life stirs. It's the ultimate stillness, the final quiet. To make this concept more relatable, picture a game of pool. When you break the rack, the balls scatter across the table, full of energy and motion. But as the game progresses, the balls slow down, eventually coming to rest. The universe, in a way, is like that pool table. Right now, it's teeming with activity, stars exploding, galaxies colliding, planets forming. But over trillions upon trillions of years, that energy will dissipate, and the universe will reach its final, static state. The heat death isn't just a scientific idea. It's a profound reflection on the nature of existence. It forces us to confront the inevitability of change and the impermanence of everything we know. Yet, even in this bleak scenario, there's a strange kind of beauty, a reminder that the universe, like all things, has a beginning, a middle, and an end. But what if the end isn't so gradual? What if time doesn't just fade away but comes to a sudden, dramatic halt? That's where our next theory takes us, a scenario far more abrupt and explosive than the slow, inevitable heat death. Let's dive into that next. Imagine a force so powerful that it could rip apart the very fabric of existence, not just planets or stars, but the atoms that make up everything we know. This is the chilling possibility behind the third theory, the Big Rip. Unlike the Big Crunch or the heat death of the universe, this scenario hinges on the mysterious nature of dark energy, the enigmatic force driving the universe's accelerated expansion. If dark energy continues to grow stronger over time, it could one day overwhelm all other forces in the cosmos, tearing apart galaxies, solar systems, and even the bonds holding atoms together. The timeline for such an event is staggering. In roughly 22 billion years, if dark energy behaves as some models predict, the universe could reach a point where expansion outpaces gravity's ability to hold things together. First, galaxies would drift apart, no longer bound by their mutual gravitational pull. Then, stars within those galaxies would be flung into the void, their light fading into an endless, dark expanse. But the most terrifying stage comes last, the moment when the forces holding atoms together are no match for the relentless push of dark energy. Matter itself would disintegrate, leaving behind a universe of scattered particles, unable to ever form anything again. This isn't just the end of life or planets, it's the end of the fundamental building blocks of reality. Space and time, the very framework of existence, would unravel. The concept of now or later would lose meaning as the fabric of spacetime itself is stretched and shattered. It's a fate so extreme, it challenges our understanding of what the universe even is. And yet, the Big Rip isn't the only theory that hints at time itself breaking down. What if the flow of time, something we take for granted, could be disrupted or destroyed? What happens when the clock stops ticking, not just for us but for the entire cosmos? What if the very fabric of reality is as fragile as a house of cards teetering on the edge of collapse? This brings us to our fourth chilling theory, the end of time through quantum fluctuations. At the heart of quantum mechanics lies the strange and unpredictable behavior of particles at the smallest scales. Even in what we perceive as empty space, particles pop in and out of existence, creating a chaotic dance of energy. These tiny, random fluctuations are usually harmless, just the universe's way of keeping things interesting on the quantum level. But what if they weren't? What if, under the right conditions, these fluctuations grew out of control, destabilizing the laws of physics themselves? Imagine this: a single quantum event, so small it's almost imperceptible, triggers a ripple effect. Perhaps a fluctuation causes a fundamental constant like the speed of light or the strength of gravity to shift ever so slightly. At first, nothing seems amiss. But over time, this small change could cascade into something catastrophic. The stability of space-time, the very framework that allows time to flow, could begin to unravel. The result, time itself could collapse, ceasing to exist in any meaningful way. It's a scenario that feels like science fiction, but it's rooted in the bizarre realities of quantum theory. To make this even more tangible, think of a calm lake. On the surface, everything looks still, but beneath, tiny currents and eddies are constantly swirling. Now, imagine one of those eddies suddenly growing larger and larger until it disrupts the entire lake. In the same way, a quantum fluctuation could grow from a microscopic event into a universe-altering catastrophe. And while this might sound like an abstract concept, scientists have already observed similar phenomena in controlled experiments, where particles appear to defy the laws of classical physics. It's not a huge leap to consider that such behavior could, under extreme conditions, bring about the end of time as we know it. Now, let's take this idea one step further and consider the role of black holes. These cosmic giants are already known for warping spacetime to its limits. Near a black hole, time slows down dramatically due to its immense gravitational pull. But what if a quantum fluctuation occurred within a black hole's event horizon? Could such an event amplify the instability, causing a chain reaction that spreads beyond the black hole and into the rest of the universe? Some theories suggest that black holes might be the ultimate testing grounds for the limits of quantum mechanics, places where the rules of physics break down entirely. If a fluctuation were to occur in such an extreme environment, it could potentially trigger the collapse of time on a cosmic scale. This theory is as unsettling as it is fascinating, reminding us how delicate the balance of our universe truly is. From the tiniest particles to the most massive black holes, the interplay of quantum mechanics and gravity could hold the key to understanding not just the beginning of time, but its ultimate end. Black holes, those mysterious, all-consuming giants of the cosmos, might hold the key to how time itself could come to an end. Imagine a universe where these gravitational behemoths dominate, slowly pulling in every star, planet, and speck of dust until nothing remains but darkness. Over billions of years, black holes could grow larger and more numerous, eventually devouring everything in their path. In such a scenario, time as we know it would lose all meaning. With no stars to mark its passage, no planets to orbit, and no life to experience its flow, the universe would become a silent, timeless void. But even black holes aren't eternal. Thanks to a phenomenon called Hawking radiation, these cosmic monsters slowly lose mass over unimaginable timescales, trillions upon trillions of years. As they emit this faint radiation, they shrink, eventually evaporating completely. At that point, the universe would be left with nothing but a faint haze of particles, drifting endlessly in an infinite expanse. Time without any meaningful events to measure would cease to have any purpose. Yet, even in this bleak vision of the far future, some theories offer a glimmer of hope. What if black holes aren't the end, but gateways to something else entirely? Some scientists speculate that these gravitational titans could act as portals to other universes, parts of a vast multiverse where time and reality operate under entirely different rules. While this idea pushes the boundaries of our understanding, it raises fascinating questions about what might lie beyond the boundaries of our own universe. Could the end of one reality simply mark the beginning of another? The mysteries of black holes and their role in the ultimate fate of time remain some of the most captivating puzzles in science. What if the end of time doesn't come from within our universe but from beyond it? This brings us to the sixth chilling theory, the collision of parallel universes. Imagine our universe as one bubble floating in a vast, infinite ocean of other bubbles, each one a separate universe with its own laws of physics, its own timeline, and its own destiny. Now picture two of these bubbles drifting closer and closer until they collide. The scientific foundation for this idea comes from string theory and brane cosmology. In these models, our universe isn't just a standalone entity, it's a membrane or brane floating in a higher dimensional space. These branes can move, vibrate, and even crash into one another. When they do, the energy released could be catastrophic, potentially rewriting the very fabric of reality as we know it. Think of it like two soap bubbles merging in slow motion. At first, they gently touch, but as they come together, the surface tension causes a sudden burst of energy. In the same way, a collision between universes could unleash unimaginable forces, tearing apart space and time in an instant. This wouldn't just be the end of our universe, it could mean the end of time itself. But here's the twist: what if such a collision doesn't happen in a dramatic explosion? What if it's more subtle, like a quiet merging of timelines? Could time end not with a bang, but with a whisper? This leads us to the next question. are there other, less violent ways time could unravel? What if the very fabric of reality, the foundation of everything we know, could unravel in an instant? This is the unsettling possibility at the heart of the seventh theory, the decay of the vacuum. At first glance, it might sound like science fiction, but this idea is rooted in some of the most cutting-edge concepts in particle physics. It all begins with something called a false vacuum. In simple terms, a vacuum is space devoid of matter, but in physics, it's also the lowest energy state in the universe, a kind of baseline for reality. However, scientists speculate that our universe might not be in the true lowest energy state. Instead, we could be living in a false vacuum, a sort of cosmic metastable bubble. Think of it like a marble resting in a shallow bowl. It seems stable, but if something nudges it hard enough, it could roll out into a deeper valley. If our universe is in a false vacuum, a similar shift could occur, rewriting the very laws of physics as we know them. This shift, known as vacuum decay, would start with a single point in space. A tiny bubble of true vacuum could form, and as it expands at the speed of light, it would obliterate everything in its path. The laws of physics inside this bubble would be completely different. Fundamental forces like gravity or electromagnetism might cease to exist as we understand them. Stars, planets, and even time itself could be erased in an instant. Now you might wonder, what could trigger such a catastrophic event? Surprisingly, it could be something as small as a single particle collision in a particle accelerator or even a random quantum fluctuation. The terrifying part is that we wouldn't see it coming. The bubble would expand so quickly that there'd be no warning, no time to react. It's a cosmic reset button, wiping out the universe in a fraction of a second. But what does this mean for time? If the laws of physics are rewritten, time as we experience it, a linear progression from past to future, could cease to exist. Time itself might become meaningless, replaced by an entirely new framework we can't even begin to comprehend. This theory takes us to the edge of what we understand about the universe, blending particle physics with the nature of time. It's a chilling reminder of how fragile our reality might be, and how much we still have to learn about the cosmos. And as we explore further, we'll dive into theories that challenge our understanding of time itself, what it is, how it works, and whether it could ever truly come to an end. What if time as we know it isn't real? What if it's just a construct, a trick of the mind, or a byproduct of how we perceive the universe? This is the heart of the eighth theory, the idea that time itself might be an illusion. Philosophers and physicists have debated this for centuries, and it's a concept that turns our understanding of reality on its head. If time isn't a fundamental aspect of the universe, then the end of time might not mean destruction or collapse. It could simply mean the moment we finally see through the illusion. From a philosophical standpoint, thinkers like Immanuel Kant argued that time is a framework our minds impose on the world, not something that exists independently. It's how we make sense of change and motion, but it might not be a feature of the universe itself. In the realm of physics, some interpretations of quantum mechanics suggest that time might not flow at all. Instead, everything that has ever happened or will happen could exist simultaneously, like frames in a film reel. We experience it sequentially because of how our consciousness works, but the flow of time might be nothing more than a trick of perception. To challenge this idea, let's try a thought experiment. Imagine the universe as a vast, unchanging block, a block universe, as physicists call it. In this model, past, present, and future all exist at once. Your birth, your life, and even your death are all equally real, just located in different parts of this block. If this is true, then the concept of time ending doesn't make sense, because time isn't something that moves or changes. It's just a dimension like space. The end of time, in this view, might simply be the moment we stop perceiving it as linear. But what does this mean for the future of the universe? If time is an illusion, then the end of time might not involve any dramatic cosmic event. Instead, it could be a shift in our understanding, a realization that the universe doesn't operate on a timeline. It's a radical idea, but it opens the door to even more fascinating possibilities, like the idea of cosmic cycles, where the universe repeats itself endlessly. If time isn't real, perhaps the universe isn't bound by beginnings or endings at all. Instead, it might exist in an eternal loop, with patterns repeating across dimensions we can't yet comprehend. This brings us to the next theory, the idea of cosmic cycles, where the universe might not have a single, definitive end, but instead experiences endless rebirths. Could the end of time be just the start of something new? What if time isn't a straight line but a loop, endlessly repeating itself? This is the heart of the ninth theory, known as eternal recurrence. Picture the universe as a cosmic wheel, spinning through cycles of birth, death, and rebirth. Each cycle begins anew, with time resetting itself, and everything that has happened, every star, every galaxy, every moment of existence repeating in an infinite loop. It's a concept that has fascinated thinkers for centuries, from ancient philosophers like the Stoics and the Mayans to modern cosmologists exploring the mysteries of the cosmos. At its core, eternal recurrence suggests that the universe isn't moving toward a single, ultimate end, but is instead caught in an unending dance of creation and destruction. Think of it like a cosmic heartbeat, expansion and contraction, over and over, with each cycle potentially identical to the last. Some interpretations even propose that every event, every decision, and every moment you've experienced will happen again in exactly the same way. It's a haunting thought, isn't it, that the choices you make now might echo eternally, replaying in an infinite cosmic loop. Modern science has found echoes of this idea in theories like the Big Bounce, which suggests that our universe could be just one in a series of expansions and contractions. Instead of a one-time Big Bang, the universe might collapse and then explode anew over and over again. This cyclical model aligns with the ancient idea of eternal recurrence, blending philosophy with cutting-edge physics. But here's the twist: what if, in each cycle, the laws of physics themselves begin to break down? What if time itself becomes unstable, unraveling the very fabric of reality? That's where things get even more mind-bending. As we ponder these cycles, it's worth asking, could there be a way to break free from this endless loop, or are we destined to repeat it forever? And what happens if the rules of the universe start to crumble in the process? The answers might lie in the next theory, where the breakdown of physical laws takes center stage. What if the very fabric of reality, the rules that hold the universe together, began to unravel? This brings us to our 10th chilling theory, the breakdown of physical constants. Imagine the speed of light, the gravitational constant, or even the charge of an electron. These aren't just numbers in a textbook. They're the foundation of how everything works, from the tiniest particles to the vast expanse of space. But what if these constants weren't so constant after all? Scientists have long assumed that these values are fixed, unchanging pillars of reality. But some theories suggest they might shift over time, even if only by a tiny fraction. At first, it might not seem like a big deal after all. How much could a slight change in the speed of light really matter? But here's the catch. These constants are so finely tuned that even the smallest deviation could throw the entire universe into chaos. Atoms might not hold together, stars could stop burning, and even space-time itself could begin to collapse. It's like pulling a single thread from a tapestry, everything unravels. Take, for example, the fine structure constant, a number that governs how light interacts with matter. If this constant changed, chemistry as we know it might cease to exist. Reactions that power life, like photosynthesis, could fail. The delicate balance that allows planets to form and galaxies to spin could be shattered. And if space-time itself starts to break down, well, the consequences are almost beyond imagination. Time might no longer flow in one direction, and cause and effect could become meaningless. The universe would lose its structure, its order, and its ability to support anything resembling life. This idea isn't just science fiction, it's rooted in real physics. Some researchers have speculated that if certain constants were to shift, it could signal the beginning of the end for our universe. And while this might sound terrifying, it also opens the door to even stranger possibilities. What if the breakdown of these constants isn't random? What if it's part of a larger process, one that could rewrite the rules of reality itself? This leads us to theories that challenge our understanding of causality, the idea that every effect must have a cause. If the constants that govern the universe can change, what does that mean for the fundamental laws of cause and effect? Could the universe reach a point where nothing makes sense anymore, where the very idea of before and after no longer applies? The breakdown of physical constants isn't just a hypothetical scenario, it's a window into how fragile our reality might truly be. And as we explore these ideas, we're forced to confront the unsettling possibility that the universe as we know it might not be as stable as we think. What if the very fabric of reality, cause and effect, suddenly unraveled? Picture a universe where every action no longer guarantees a reaction, where the laws that govern our understanding of time and space dissolve into chaos. This is the unsettling premise behind the 11th theory, the end of causality. In such a reality, events wouldn't follow predictable patterns. Instead, they'd unfold randomly like dice tumbling endlessly in the void. Time as we know it would lose its structure, becoming a meaningless concept in a world where nothing leads to anything else. The implications are staggering, both philosophically and scientifically. On a philosophical level, the breakdown of causality challenges our most fundamental assumptions about existence. If cause and effect no longer apply, free will, responsibility, and even identity could become meaningless. How could we make decisions if our actions no longer produce predictable outcomes? And what would it mean to be you in a universe where your choices don't shape your future? From a scientific perspective, the collapse of causality would dismantle the very foundation of physics. Every equation, every model we use to describe the universe relies on the idea that causes precede effects. Without this principle, the universe would descend into an unpredictable, lawless state. Imagine trying to predict the weather, only to find that storms appear and vanish without reason. Or consider the consequences for technology. Computers which rely on logical sequences of cause and effect would cease to function. The world as we know it would unravel. To help visualize this, let's engage in a thought experiment. Imagine you're standing in a room with a light switch. In our current universe, flipping the switch causes the light to turn on. But in a causality-free world, flipping the switch might do nothing, or it might cause the light to turn on, off, or even explode all at random. There's no way to predict the outcome, no matter how many times you try. This randomness isn't just confined to small events. It could scale up to cosmic proportions. Stars might flicker in and out of existence. Galaxies could collapse or expand unpredictably, and the universe itself might become a place of pure, unfathomable chaos. This theory isn't just a flight of fancy, it has roots in some of the most cutting-edge ideas in physics. Quantum mechanics, for example, already hints at a universe where unpredictability plays a role. At the quantum level, particles can behave in ways that seem to defy classical notions of cause and effect. Some physicists speculate that under extreme conditions, such as near the singularity of a black hole or at the birth of the universe, causality might break down entirely. Could this be a glimpse of a universe where time itself is no longer linear? As we grapple with these ideas, it's worth considering how they connect to another mind-bending concept, the collapse of dimensions. If causality unravels, could the dimensions of space and time also crumble? Theories in string theory and quantum gravity suggest that higher dimensions might exist beyond the four we experience. If these dimensions were to collapse or become unstable, the consequences would be unimaginable. the very framework of reality could shift, leading to a universe where time, space, and causality are no longer what they seem. What if the very structure of our universe is far more complex than the three dimensions we experience every day? According to string theory, there could be as many as 10 or even 11 dimensions woven into the fabric of reality. These higher dimensions are thought to be curled up or hidden at such tiny scales that we can't perceive them directly. But what if these extra dimensions so crucial to the framework of the universe were to collapse? The consequences could be catastrophic, leading to the end of time itself. Imagine our universe as a tower of cards. Each card represents a dimension, stacked carefully to hold the structure together. Now picture one of those cards suddenly slipping out of place. The entire tower wobbles, teeters, and then crash. In this scenario, the collapse of higher dimensions would destabilize space-time, unraveling the very fabric that holds everything together. Gravity, light, and even the flow of time could be thrown into chaos. But how exactly would this happen? In string theory, particles are not just tiny dots but vibrating strings, and these strings require higher dimensions to exist. If those dimensions were to collapse, the strings would lose their stability, causing particles to disintegrate. Without particles, there's no matter. Without matter, there's no universe as we know it. Time, which depends on the orderly progression of events, would lose its meaning, dissolving into a state of timelessness. To visualize this, think of a rope fraying at the edges. Each strand represents a dimension, and as they unravel, the rope's strength diminishes. In the same way, the collapse of higher dimensions would weaken the structure of spacetime, leading to its eventual breakdown. This isn't just a dramatic thought experiment, it's a real possibility that physicists have explored. And what about the end of information? If spacetime itself were to disintegrate, all the information stored within it, every memory, every event, every piece of knowledge would vanish. It's as if the universe's hard drive were wiped clean, leaving behind nothing but a void. This idea ties into theories like the information paradox, where the loss of information could signal the ultimate end of time. The collapse of higher dimensions is a chilling reminder of how fragile the cosmos might be. It challenges us to think beyond the limits of our perception and consider the profound mysteries that lie hidden in the fabric of reality. But what if the very fabric of reality is built on information, and that information starts to unravel? This brings us to the 13th theory, the information paradox. At the heart of this idea lies a fundamental conflict between quantum mechanics and general relativity, two of the most successful frameworks we have for understanding the universe. And it all begins with black holes. When matter falls into a black hole, it disappears from our observable universe, seemingly taking all its information with it. But here's the problem. According to quantum mechanics, information can never truly be destroyed. It might change form, but it should always be recoverable in some way. Black holes, however, seem to break this rule. They consume information, and when they eventually evaporate through a process called Hawking radiation, what's left behind appears to be nothing but random thermal energy. No trace of the original information. This paradox has led physicists to question whether time itself could break down under such extreme conditions. If information is lost, the very foundation of causality, the orderly sequence of cause and effect that defines time, could collapse. Imagine a library where books vanish the moment you close them, and every story becomes impossible to retell. Without information, the past, present, and future lose their meaning. To resolve this, some scientists propose the holographic principle, a mind-bending idea that suggests all the information in a three-dimensional space could be encoded on a two-dimensional surface at its boundary. Think of it like a hologram, a flat image that contains all the data needed to recreate a three-dimensional object. In this view, the information swallowed by a black hole isn't truly lost, it's just stored in a way we don't yet fully understand. But if the holographic principle is correct, it forces us to reconsider the nature of reality itself. Are we living in a universe that's fundamentally two-dimensional, with the third dimension just an illusion? And if so, what does that mean for time? Could it, too, be a projection of something deeper and more fundamental? Quantum mechanics offers another layer to this puzzle. In the quantum world, particles exist in a state of superposition. They can be in multiple states at once until observed. This suggests that information isn't just stored, it's constantly in flux, shaped by interactions and observations. If time is built on this foundation, its stability could depend on the preservation of information. Lose that, and time itself might dissolve into chaos. Now consider what happens when entropy, the measure of disorder in a system, reaches its maximum. In a universe where entropy can no longer increase, time as we know it might cease to have any direction or meaning. It's a chilling thought. The end of entropy could mark the end of time, leaving the universe in a state of eternal stillness. So, could the loss of information in black holes be the first domino to fall in a chain reaction that unravels time itself? The answer to that question might not just reshape our understanding of the cosmos, it could redefine what it means to exist within it. What if the universe itself decided to rewind, not just in time, but in the very fabric of how reality operates? This brings us to the 14th theory, the reversal of entropy. Entropy, the measure of disorder in the universe, is often seen as the driving force behind the arrow of time. It's why we remember the past but not the future, why ice melts in warm water but never spontaneously refreezes. But what if entropy suddenly reversed? In this scenario, the universe would begin to move backward. Chaos would give way to order, broken glass would reassemble itself, and time itself would flow in reverse. Imagine a world where effects precede causes, where the sound of thunder comes before the lightning strike. This isn't just a quirky thought experiment, it's a profound challenge to our understanding of causality. If time ran backward, would we even notice, or would our memories and perceptions flip, making the backward flow feel as natural as the forward one we experience now? The implications of this are staggering. The very laws of physics as we know them would unravel. Thermodynamics, the foundation of how energy and matter interact, would operate in reverse. Stars would reabsorb their light, galaxies would collapse inward, and the universe would march backward toward its origin. But here's the twist: if entropy reversed, would consciousness still exist? Would we even be aware of this cosmic rewinding, or would our minds unravel along with the universe? This leads us to an even deeper question. Could the reversal of entropy mark the end of consciousness itself? If time flows backward, does the continuity of thought and experience break down? It's a chilling possibility, a universe where not only time but also the very essence of awareness is undone. And as we ponder this, we step into a new realm of theories, those that explore the end of consciousness, not just as a byproduct of cosmic events, but as a fundamental shift in the nature of existence. What if time itself is nothing more than a projection of our own minds? This is the startling premise behind the 15th theory, the end of consciousness. Think about it. Our experience of time is deeply tied to how we perceive the world. Without consciousness, does time even exist? Philosophers have long debated whether time is an objective reality or a subjective creation of the human brain. And modern neuroscience offers some intriguing clues. Studies show that our brains construct time through a series of neural processes, stitching together moments into what feels like a continuous flow. But if consciousness were to vanish, would this flow simply unravel? Take, for example, the phenomenon of anesthesia. When a person is under its effects, their conscious experience of time disappears entirely. Hours can pass in what feels like an instant. This suggests that time, as we know it, is deeply intertwined with our awareness. Some scientists argue that without consciousness, the concept of time loses its meaning. It's not just a philosophical musing. This idea has profound implications for our understanding of reality. If time is a mental construct, then its end could coincide with the end of conscious minds. But let's take this a step further. If consciousness is the key to time's existence, what happens when we consider the multiverse? Some theories propose that our universe is just one of countless others, each with its own timeline and laws of physics. In this vast cosmic landscape, the end of consciousness in one universe wouldn't necessarily mean the end of time everywhere. However, if consciousness is a universal phenomenon, something that exists across all realities, then its extinction could ripple through the multiverse, collapsing time itself on a scale we can barely comprehend. This theory doesn't just challenge our understanding of time, it raises questions about the nature of existence itself. Are we merely observers in a universe that exists independently of us, or are we active participants, shaping reality with our minds? The answers may lie at the intersection of neuroscience, philosophy, and cosmology, where the boundaries of what we know blur into the mysteries of what we don't. What if the very fabric of reality, not just our universe but all possible universes, were to collapse? Picture this: an infinite web of branching timelines, each representing a different version of existence, suddenly unraveling into nothingness. This is the chilling scenario proposed by the 16th theory, the collapse of the multiverse. In this framework, our universe is just one thread in a vast tapestry of realities, each shaped by countless decisions and events. But what if something catastrophic were to sever the threads holding this tapestry together? At the heart of this theory is the idea that the multiverse isn't just a collection of disconnected realities. It's a dynamic system bound by the same fundamental laws of physics. If those laws were to break down, perhaps due to a cosmic imbalance or a shift in the underlying structure of spacetime, the entire multiverse could collapse. This wouldn't just mean the end of our universe, it would mean the annihilation of every possible timeline, every alternate reality, and every potential future. The implications are staggering. It challenges our understanding of time itself, suggesting that time isn't a linear progression but a fragile, interconnected network that could vanish in an instant. To visualize this, think of the multiverse as a vast tree with infinite branches, each representing a different outcome of every decision ever made. Now imagine that tree being uprooted, its branches withering away one by one. The collapse of the multiverse would be like watching every possible version of existence, every triumph, every tragedy, every what if disappear into the void. It's a haunting reminder of how fragile the foundations of reality might truly be. But what could trigger such a catastrophic event? Some theorists speculate that the multiverse could collapse if its expansion reaches a critical point, causing spacetime to destabilize. Others suggest that a collision between parallel universes could set off a chain reaction, tearing apart the fabric of existence. And then there's the possibility that the multiverse itself is governed by a higher dimensional structure, one that could fail under the weight of its own complexity. These ideas push the boundaries of our understanding, forcing us to confront the unsettling idea that all of existence might be far more precarious than we've ever imagined. As we grapple with the concept of the multiverse's collapse, it's impossible not to wonder, what would that mean for the nature of reality? If every possible timeline were to end, would time itself cease to exist? Or would it simply reset like a cosmic clock, winding down and starting over? These questions lead us into even deeper mysteries about the ultimate fate of spacetime and the forces that may one day bring it to an end. What if time itself could unravel? Picture the fabric of spacetime, a delicate tapestry woven from gravity, matter, and energy beginning to fray at the edges. This isn't just science fiction. It's a real scientific possibility rooted in some of the most cutting-edge theories of physics. Imagine spacetime not as an unbreakable structure, but as something that could fracture, dissolve, or even collapse entirely. If that happens, time as we know it could simply cease to exist. At the heart of this idea lies quantum gravity, a field of study that seeks to unite the rules of quantum mechanics with Einstein's theory of general relativity. In our everyday world, gravity is the force that keeps planets in orbit and holds galaxies together. But when you zoom into the tiniest scales, down to the quantum level, gravity behaves in ways we don't yet fully understand. One leading theory, loop quantum cosmology, suggests that spacetime might not be continuous. Instead, it could be made up of tiny, indivisible loops or grains, almost like pixels in a cosmic image. And just as a digital image can glitch or break apart, spacetime itself might one day reach a point where these loops destabilize, leading to a catastrophic breakdown. To make this more relatable, think of spacetime as a sheet of ice on a frozen lake. Under the right conditions, the ice is solid and stable. But if the temperature rises or the ice becomes too thin, it can crack, shatter, or even melt away entirely. In the same way, extreme cosmic conditions like the intense gravitational forces near a black hole or the unimaginable pressures at the birth of the universe could push spacetime to its breaking point. If that happens, time itself could fracture, leaving us in a reality where cause and effect no longer apply, and the very concept of before and after becomes meaningless. This theory also ties into another profound idea, the end of the universe's expansion. For decades, scientists have observed that the universe is expanding at an accelerating rate, driven by a mysterious force known as dark energy. But what if this expansion doesn't continue forever? Some models suggest that dark energy could eventually weaken or reverse, causing the universe to collapse back in on itself. This Big Crunch scenario could destabilize spacetime on a cosmic scale, leading to its ultimate breakdown. The idea of spacetime unraveling is as unsettling as it is fascinating. It challenges our understanding of reality itself and raises questions about the very nature of existence. What would it mean for time to end? Could there be a beyond where new structures of reality emerge? These are the kinds of questions physicists are grappling with as they explore the boundaries of our universe. And while the answers remain elusive, one thing is certain: the breakdown of spacetime isn't just a distant possibility. It's a reminder of how fragile and extraordinary the fabric of our reality truly is. Imagine a universe that isn't racing outward in a chaotic frenzy, but instead slows to a halt, as if time itself has taken a deep breath and stopped moving. This is the essence of the 18th theory, the end of expansion. For billions of years, the cosmos has been stretching, galaxies drifting apart as space itself expands. But what if this expansion isn't infinite? What if one day it just stops? At the heart of this theory lies the concept of dark energy, the mysterious force driving the universe's acceleration. Right now, dark energy seems to have the upper hand, pushing galaxies apart faster and faster. But some scientists speculate that this force could weaken over time. If dark energy loses its grip, the expansion could slow, eventually grinding to a complete stop. The universe would reach a state of equilibrium, a frozen, static expanse where nothing moves, nothing changes. Time as we know it would lose all meaning. Picture this: a cosmos where stars no longer burn, galaxies no longer collide, and the fabric of space itself becomes still. No new stars would form, no new planets would emerge. The universe would enter a timeless state, a cosmic pause that stretches on forever. It's a chilling thought, isn't it? A universe that's not dead, but frozen like a photograph of a moment that never ends. This scenario raises profound questions about the nature of existence. Would life still have a place in such a universe? Could consciousness even exist in a timeless void? And what would it mean for the concept of progress or evolution? These are questions that stretch the limits of our imagination, challenging us to think beyond the boundaries of time itself. But the end of expansion isn't the only fate the universe might face. As we explore the possibilities of a frozen cosmos, another question arises. What happens to the matter within it? This leads us to theories that delve into the ultimate fate of matter itself, theories that suggest even the building blocks of reality might not last forever. And that's where our journey takes us next. Imagine a universe where everything, every star, every planet, even the atoms that make up your body, slowly crumbles into nothingness. This is the chilling possibility behind the 19th theory, the decay of matter. According to this idea, the very fabric of the universe could dissolve over unimaginable timescales, leaving behind a cold, empty void filled only with radiation. But how could this happen? The key lies in something called proton decay. Protons, the building blocks of atomic nuclei, are thought to be incredibly stable. We've never observed one decaying in nature, but some theories in particle physics suggest that even protons might not last forever. Under certain conditions, protons could break down into lighter particles, eventually transforming into pure energy. This process, if it occurs, would happen over an almost incomprehensible span of time, trillions upon trillions of years. But if protons do decay, the implications are staggering. Stars, planets, and even the atoms in your body would eventually disintegrate, leaving no trace of the complex structures that define our universe. Scientists have long searched for evidence of proton decay, using massive detectors buried deep underground to shield them from cosmic interference. So far, no definitive proof has been found, but the search continues, driven by the tantalizing possibility that even the most stable particles in the universe might not be eternal. If protons do decay, it would mean that all matter is, in a sense, on borrowed time. This theory ties into a broader concept, the idea that the universe might not just end with the death of stars or the expansion of space, but with the slow, inevitable unraveling of its most basic components. As matter decays into radiation, the universe would lose its structure, becoming a featureless sea of energy. Without matter, there would be no more galaxies, no more planets, and no more time as we understand it. The universe would simply fade into a state of uniformity where nothing changes and nothing happens, a true end of everything. But what about energy itself? If matter decays into radiation, could energy also meet its end? This leads us to even more profound questions about the ultimate fate of the universe, questions that take us to the very edge of our understanding of physics. Could energy, too, dissipate or transform into something entirely different? Theories about the end of energy open up a new frontier of possibilities, each more mind-bending than the last, and they remind us just how fragile the universe might truly be. What if the universe itself simply runs out of fuel? This is the chilling premise behind the 20th theory, the end of energy. Picture a cosmos where every star has burned out, every black hole has evaporated, and every particle has decayed into its most basic form. In this distant future, the universe could reach a state known as heat death, where all usable energy is exhausted, and entropy, the measure of disorder, reaches its maximum. Time, as we understand it, would effectively cease to have meaning. This idea stems from the laws of thermodynamics, which govern the behavior of energy in our universe. The second law, in particular, tells us that energy naturally spreads out and becomes less useful over time. Think of it like a campfire slowly burning out. The heat dissipates, the embers cool, and eventually nothing is left but ash. Now imagine that same process happening on a cosmic scale. Over trillions of years, galaxies would fade, stars would dim, and even the most fundamental particles would decay into radiation. The universe would become a vast, cold, and lifeless expanse, devoid of any structure or activity. But what does this mean for time? If there's no change, no movement, and no energy to power any processes, does time even exist? Some physicists argue that time itself is a byproduct of change, a way for us to measure the progression of events. In a universe where nothing happens, time might as well be irrelevant. It's a strange and unsettling thought, a reality where the clock stops ticking, not because it's broken, but because there's simply nothing left to measure. To challenge this idea, let's take a step back and consider the quantum realm. At the smallest scales, particles behave in ways that defy our everyday understanding of reality. Quantum fluctuations, tiny, random changes in energy are constantly happening, even in what we might consider empty space. So, could these fluctuations prevent the universe from reaching total stillness? Or would even the quantum realm eventually succumb to the relentless march of entropy? These questions push the boundaries of our understanding, hinting at deeper mysteries about the nature of time, energy, and existence itself. As we explore these ideas, we begin to see how the end of energy ties into even more profound questions about the universe's ultimate fate. What lies beyond the heat death? Could there be a way for the universe to reset, or is this truly the final chapter? These are the kinds of questions that lead us into the next realm of possibilities, theories that involve the end of the quantum realm and the strange, almost unimaginable scenarios they propose. What if the very foundation of reality itself could unravel? This brings us to the 21st chilling theory, the collapse of the quantum realm. At the heart of this idea lies the unsettling possibility that the quantum world, the realm of particles and probabilities that underpins everything we know, could destabilize. If the quantum realm were to collapse, it wouldn't just disrupt atoms or molecules. It could unravel the fabric of space-time, effectively bringing time itself to an end. To understand this, let's take a step into the bizarre world of quantum mechanics. In this realm, particles exist in a state of superposition, meaning they can be in multiple places or states at once until observed. This delicate balance is what allows reality to function as we know it. But what if this balance were to fail? Some physicists speculate that a catastrophic collapse of the quantum realm could occur, possibly triggered by an unknown force or a fundamental flaw in the laws of physics. The result, a cascading failure of the universe's most basic building blocks, leading to the abrupt cessation of time. The implications are staggering. If the quantum realm collapses, the very concept of cause and effect could dissolve. Events might no longer follow a logical sequence, and the universe could devolve into chaos. Even space-time, the stage on which all existence plays out, could fracture, leaving behind a void where time no longer flows. It's a scenario that challenges our understanding of reality itself, forcing us to confront the fragility of the cosmos. This theory isn't just speculative, it's rooted in the strange and often counterintuitive principles of quantum mechanics. For instance, the phenomenon of quantum entanglement, where particles remain connected across vast distances, suggests that the universe operates on a deeply interconnected level. If this interconnectedness were to break down, the ripple effects could be catastrophic. Imagine a cosmic tapestry unraveling thread by thread until nothing remains but a formless void. From here, we can transition to another chilling possibility, the end of the cosmic web. The cosmic web, a vast network of galaxies and dark matter, is the scaffolding of the universe. Its stability is crucial to the existence of galaxies, stars, and planets. But what if this cosmic structure were to collapse? The consequences would be as profound as the collapse of the quantum realm, reshaping our understanding of the universe's ultimate fate. The universe as we know it is held together by an intricate, invisible tapestry, the cosmic web. This vast network of dark matter and galaxies stretches across billions of light years, connecting everything in a delicate balance. But what if this cosmic web began to unravel? What if the very fabric holding the universe together started to dissolve? This is the foundation of the 22nd theory, the dissolution of the cosmic web, a scenario that could lead to the end of time itself. At the heart of this theory lies the interplay between dark matter and dark energy. Dark matter, the unseen glue that binds galaxies together, gives the cosmic web its structure. Without it, galaxies would drift apart and the universe would lose its shape. Dark energy, on the other hand, is the mysterious force driving the accelerated expansion of the universe. It's like a cosmic tug-of-war, dark matter pulling things together while dark energy pushes them apart. But what happens if dark energy gains the upper hand? Scientists speculate that if dark energy continues to dominate, it could eventually tear apart the cosmic web. Galaxies would drift further and further away, becoming isolated islands in an ever-expanding void. The connections that bind the universe together would weaken, and over time, the cosmic web could dissolve entirely. Without this structure, the universe would lose its coherence, and the flow of time itself could become meaningless. To visualize this, picture the cosmic web as a spider's silk thread shimmering in the morning dew. It's strong enough to hold the intricate patterns of the universe, but if that thread were to snap, the web would collapse into chaos. In the same way, if the cosmic web dissolves, the universe could descend into a state of disorder where time no longer has a direction, no past, no future, just an endless, formless expanse. This idea ties into another profound concept, the end of the arrow of time. In physics, the arrow of time represents the one-way flow from past to future, driven by the increasing entropy or disorder of the universe. But if the cosmic web dissolves and the universe reaches maximum entropy, time could lose its forward momentum. Events would no longer unfold in a linear sequence, and the very notion of cause and effect could break down. As we explore these theories, it's worth asking, what would it mean for existence if time itself ceased to flow? Could the universe continue in some form, or would it simply fade into an eternal stillness? These questions push the boundaries of our understanding, reminding us just how fragile the fabric of reality might be. What if everything we know about time is flipped upside down? Imagine a universe where the past becomes the future, where causes follow effects, and where the very fabric of reality seems to run backward. This is the startling possibility of the reversal of the arrow of time. In our everyday lives, time moves forward. We're born, we grow old, and events unfold in a linear sequence. But what if that's not the only way it could work? The arrow of time is a concept that describes the one-way direction of time from past to future. It's why we remember yesterday but not tomorrow, and why a shattered glass doesn't spontaneously reassemble itself. But some theories suggest that under certain conditions this arrow could reverse. In a universe where entropy, the measure of disorder, decreases instead of increases, time might flow backward. Picture this: stars collapsing back into their birth clouds, galaxies reassembling, and life forms aging in reverse. It's a mind-bending idea, but it challenges our fundamental understanding of cause and effect. What would this mean for reality? If the arrow of time reversed, the very laws of physics as we know them could unravel. Actions would no longer have predictable consequences, and the concept of free will might become meaningless. Think about it. If the future influences the past, does that mean our choices are predetermined? Or does it imply that the past is just as malleable as the future? These questions push the boundaries of both science and philosophy. To explore this further, let's consider a thought experiment. Imagine you're watching a movie, but instead of playing forward, it's running backward. At first, it's disorienting, but eventually, you might start to see patterns or even a new kind of logic emerge. Now apply that to the universe. If time reversed, would we even notice? Or would our perception of reality adapt to this new, inverted order? It's a question that highlights just how deeply our experience of time is tied to the laws of physics. This theory also ties into the broader concept of symmetry in the universe. Many physicists believe that at the deepest level, the universe is symmetrical. What goes forward can also go backward. But if the arrow of time reverses, it could signal the end of that symmetry, leading to a universe where the rules we take for granted no longer apply. As we explore these ideas, we're left to wonder, is time as fixed as it seems, or is it just another variable waiting to be rewritten? But what if the very laws of nature, those unshakable rules that govern our universe, could unravel? This brings us to the 24th chilling theory, the breakdown of symmetry. symmetry is one of the most fundamental principles in physics, woven into the fabric of reality itself. It's what makes the universe predictable and orderly. Take, for example, the way particles behave. Electrons are identical no matter where you look in the cosmos, and the laws of physics hold true whether you're in a lab on Earth or observing a distant galaxy. But what happens if that symmetry breaks down? In particle physics, symmetries are tied to the forces that hold the universe together. The Standard Model, our best understanding of these forces, relies on symmetry to explain why particles interact the way they do. But some theories suggest that at extremely high energies or under extreme conditions, these symmetries could collapse. Imagine a spinning top. It's stable and symmetrical as long as it keeps spinning. But if it slows down, it wobbles, loses balance, and eventually falls. Similarly, if the symmetries governing our universe were to break down, the very fabric of spacetime could destabilize. Time itself might cease to flow in the orderly way we're accustomed to. The implications are staggering. Without symmetry, the laws of nature as we know them would no longer apply. Forces like gravity or electromagnetism could behave unpredictably, and particles might interact in chaotic, unprecedented ways. Some physicists speculate that this breakdown could lead to a catastrophic end for the universe, a moment when spacetime itself fractures, rendering time meaningless. It's a scenario where the universe doesn't just end with a bang or a whimper, but with a fundamental unraveling of its structure. This idea isn't purely speculative either. Experiments in particle accelerators have already observed temporary breakdowns of symmetry at tiny scales. For instance, the discovery of the Higgs boson revealed how particles gain mass through a process that involves symmetry breaking. While these events are controlled and localized, they hint at what might happen on a cosmic scale if symmetry were to fail entirely. As we delve deeper into these theories, we're left to wonder, could the end of time be tied to the collapse of the very principles that make our universe comprehensible? And if so, what would that mean for the ultimate fate of reality? These are questions that take us to the edge of our understanding, where the familiar rules of physics give way to the unknown. And it's here that we begin to explore theories about the end of the universe's structure, a topic as fascinating as it is unsettling. As we venture into the 25th and final theory, we confront one of the most profound and unsettling possibilities, the collapse of the universe's very structure. Picture the cosmos not as a static stage, but as a delicate, ever-expanding tapestry woven together by gravity, dark energy, and the laws of physics. What if one day that tapestry begins to unravel? At the heart of this theory lies the interplay between gravity, the force that pulls matter together, and dark energy, the mysterious force driving the universe's accelerated expansion. For billions of years, these two forces have been locked in a cosmic tug-of-war, shaping the universe as we know it. But what if this balance were to tip? Some scientists propose that dark energy could grow stronger over time, overwhelming gravity and causing the universe to expand so rapidly that its structure begins to fracture. Imagine a spider's web stretched too thin. At first, it holds together, but as the tension builds, it starts to tear apart strand by strand. In this scenario, galaxies, stars, and even atoms could be pulled apart, unraveling the fabric of space itself. This process, known as the Big Rip, would mark the end of time as we understand it, leaving behind a cold, empty void where nothing can exist. But there's another possibility. Instead of tearing apart, the universe could collapse inward. If gravity were to gain the upper hand, the expansion could reverse, pulling everything back into a single point, a cosmic Big Crunch. This would be the ultimate reversal, a collapse so complete that not even time could escape its grip. These theories aren't just speculative, they're grounded in our current understanding of physics. Observations of distant supernova and the cosmic microwave background have provided clues about the behavior of dark energy and the universe's expansion. Yet, the ultimate fate of the cosmos remains one of the greatest mysteries in science. As we reflect on these 25 chilling theories about the future, one thing becomes clear: the universe is a place of both beauty and uncertainty. From the heat death of the cosmos to the collapse of its structure, each theory offers a glimpse into the profound forces that shape our existence. And while the end of time may seem distant, even unimaginable, these possibilities remind us of the fragility and wonder of the universe we call home. Now, as we prepare to wrap up, let's take a moment to consider what these theories mean for us, not just as explorers of the cosmos, but as beings who are part of its vast, unfolding story. As we bring this journey to a close, let's take a moment to reflect on the 25 chilling theories we've explored about how time could end. From the heat death of the universe to the collapse of false vacuums, from the Big Crunch to the unsettling idea of time loops and quantum entanglements, one thing is clear: the universe is far stranger and more mysterious than we often realize. Each theory offers a unique lens through which to view the fragility of time and the vast, often incomprehensible forces that shape our existence. These ideas aren't just abstract speculations, they challenge us to rethink what we know about reality itself. They remind us that time, something we often take for granted, is not an infinite resource but a delicate thread woven into the fabric of the cosmos. Whether time ends in a fiery collapse, a silent fade, or a sudden quantum shift, these theories paint a picture of a universe that is both awe-inspiring and humbling. And while the thought of time's end might seem daunting, it also sparks something profound within us, an unquenchable curiosity. Time may be finite, but our desire to explore, to question, and to understand is boundless. It's this curiosity that drives us to look up at the stars and wonder, to push the boundaries of science and imagination, and to keep searching for answers in the face of the unknown. So, what do you think? Which of these theories resonated with you the most? Are there other possibilities you've pondered about how time could end? Share your thoughts in the comments below. We'd love to hear your perspective. And if you've enjoyed this exploration of the cosmos and its mysteries, don't forget to subscribe for more deep dives into the unknown. Together, let's keep questioning, keep exploring, and keep marveling at the wonders of the universe. After all, the end of time might be out there somewhere, but our journey to understand it is